Learning objectives. At the end of this topic, you will be able to draw linear graphs for the given data, understand some applications in graph. Have you seen graphs in the newspaper? Graphs are visual representations of data collected. The graph is a visual display of some data. We can understand the numerical facts in visual form. In most cases, the data exists in the form of a table. These are many different types of graphs. They are bar graph, double bar graph, pie chart, and histogram. In this lesson, we will discuss about line graph and linear graph. A line graph displays data that changes continuously over periods of time. That is, a line graph is just plotting the points in accordance with the data and joining them to form a zigzag line. Whereas a linear graph is when this connection of points gives us a straight line. Line graph. The temperature was recorded every 3 hours at Springwood over a 24-hour period. The line graph below shows the results. The horizontal axis, that is the x-axis, represents the time, and the vertical axis, that is the y-axis, represents the temperature. What was the temperature at 9 a.m.? Consider 9 a.m. in the graph. Draw a line literally up to 9 a.m. and move across it. We can see that it hit the temperature 15 degrees Celsius. So, the answer for the temperature at 9 a.m. is 15 degrees Celsius. The next question is, when did the temperature first reach 19 degrees Celsius? We know 19 degree lies between 15 and 20 degrees Celsius. 19 is here. Draw a line across it and then move vertically downward. Is exactly at 12 noon. The third question is, by how much did the temperature rise between 6 a.m. and 3 p.m.? First we look at what was the temperature at 6 a.m. At 6 a.m. reading up and across, we can see it as 7 degrees Celsius. Now we look at what was the temperature at 3 p.m. At 3 p.m. reading up and across it, we can see 20 degrees. So it started at 7 and rose to 20. From 7 to 20. It rose up by 13 degrees Celsius. Finally, we need to estimate the temperature at 7 p.m. We know 7 p.m. lies between 6 p.m. and 9 p.m. We estimate 7 p.m. would be here. Measuring upward and across, we can see a 12 degrees Celsius. So the estimated temperature at 7 p.m. is 12 degrees Celsius. Linear graph. Consider the coordinate plane. Horizontal number line is called the x-axis and the vertical number line is called the y-axis. Where these two number lines meet is called the origin and it has the ordered pair 0, 0. Here let us plot the point 5, 3. 5 is the x value. Now on the number line in the x-axis, move right 5 units. In an ordered pair 5, 3, the number 3 is a y value. We are going to move up 3 units in the x-axis. Plot the point here. This represents point 5, 3. Is it the same as the point 3, 5? Now let us plot it and verify whether the points 5, 3 and 3, 5 are the same. 3 is the x value. Move from 0, 3 units, right side in the x-axis. And move 5 units up. We reach the point 3, 5. Now you can see that the points 5, 3 and 3, 5 are two different points. Your call has been disconnected due to lack of balance. Sit down for a moment, Sanjay, and look at this. In our everyday life, the more we use the facility, the more we pay for it. So, If someone makes less phone calls, then they spend less money. And if someone speaks the whole day over a phone, then the mobile balance decreases quickly. Let us assume 1 minute phone call is 10 paise. Draw a graph to illustrate this. This x-axis represents the number of minutes, and this y-axis represents the cost of phone calls per minute. Now this graph can help us to estimate a few things. Suppose you have 60 paise balance on your phone and you want to know how many minutes you can speak. Locate 60 paise on the y-axis and follow the horizontal line until you meet this diagonal graph line. And now turn right at this point and move towards the x-axis, and you will reach at 6. This is the number of minutes you can speak at 60 paise. Here the number of minutes you can speak is called the independent variable. The cost of phone call per minute is called the dependent variable. The figure shows a graph for the distance traveled by a train between 9 a.m. and 10:20 a.m. Find the total distance traveled, total stoppage time, the period when the train was traveling at the fastest speed. The x-axis indicates the time, 1 unit equals 20 minutes. The y-axis indicates the distance traveled by the train. On the y-axis, 1 unit equals 30 kilometers. From the graph, you can see that the train started at 9 a.m. The train stops the journey at 10:20 a.m. To find the total distance traveled, draw a vertical line from points on the x-axis. Extend the lines to intersect the graph. From the intersection points on the graph, draw a horizontal line which meets the y-axis. On the y-axis, intersection corresponds to 0 kilometer at the lowest point and 120 kilometers at the highest point. To find the total distance traveled, subtract 0 from 120. We get 120 kilometers. The horizontal parts of the graph indicates that the distance does not decrease. No increase in distance implies the train does not move in that period. In the period when the train was stationary, you locate the horizontal sections of the graph and draw vertical lines in the x-axis from each. The points where the vertical lines intersect the x-axis are time when the train was not moving. Subtract the two times. Give us the stoppage time for the train. That is 9:40 a.m. minus 9:30 a.m. is equal to 10 minutes. Observe the graph. The train stops only one time during the journey. Therefore, the total stoppage time is 10 minutes. In distance time graph, this status part indicates the highest speed. This is because the status part corresponds to the greatest distance covered per unit time. To find the period when the train was traveling at the fastest speed, locate the start and end of the status point of the graph. Then draw vertical lines from the start and end points to meet x-axis. Thus, between 9:50 a.m. and 10 a.m., the train was traveling the fastest. Let's summarize the topic. Graphs are visual display of some data. We can easily understand the numerical facts in visual form. In most cases, the data exists in the form of a table. However, the same data displayed as a graph often creates more impact. There are many different types of graphs. They are bar graph, double bar graph, pie chart, and histogram. A line graph displays data that changes continuously over a period of time. That is, a line graph is just plotting the points in accordance with the data and joining them to form a zigzag line. A linear graph is different from a line graph. A line graph, which is a whole unbroken line, is called a linear graph. When you draw a graph, first start with two straight lines at right angles to each other. The horizontal line is called the x-axis of the graph. The vertical line is called the y-axis of the graph. We need x-coordinate and y-coordinate for fixing a point on the graph sheet. The relation between dependent variable and independent variable is an independent variable can have any value. whereas the dependent variable's value is determined by the independent variable.